All right, looking at problem number 1. What we've got is a polynomial in factored form, which will give us some information, but it doesn't give us all the information. If we need things like the y-intercept and the end behaviors, we really need this in standard form, not factored form. But this is going to be a big, long thing to multiply out into standard form, when really the only thing we need in the standard form are the first term and the last term. So let's get those. I'm going to do the first term up here. To get the first term, we would have this negative, and then we would have the x squared times the x cubed times x to the 1 power. And so the first term will be negative x, and let's see, 2, 3 is 5, and 1 is 6. So we know from the first term that the right hand is down, and the degree is even, so the left hand is the same as the right hand, which is down. Now, to get the last term, what we're going to do is the following. We'll have the negative, then we'll have the positive 3 squared, we'll have the negative 1 cubed, and we'll have the negative 5 to the 1 power. And if you put this in your calculator exactly like this with all the parentheses, so you don't have a problem with the negatives, that'll multiply out to negative 45. And so the last term tells us the value of the y-intercept. Now, to get the roots and the multiplicities, we take each of these linear binomials and we set them equal to 0. And we solve each of those. So if x plus 3 equals 0, when you solve that, what do you get? X equals negative 3. And the exponent is 2, that's the multiplicity. The next one, x minus 1 is 0, so x equals positive 1, and the multiplicity is 3. And x minus 5 equals 0, so x equals positive 5, and the multiplicity is 1. So now we know a bunch of information about this polynomial. We know it crosses at the x-axis at negative 3, positive 1, and positive 5. And we know the right hand and the left hand are down. And we know it crosses at negative 45 somewhere. So let's see if we can draw a possible graph for this. So I'm going to start at the right and move to the left. So from the right, we go upwards to 5. The multiplicity is 1, so it goes straight through. Then we go to positive 1 root, and the multiplicity is 3, so it does a change in curvature, goes through negative 45, and then at negative 3 root, the multiplicity is 2, so it touches and bounces back like that. Okay? Any questions? May I slide this up to the next one? Okay. So, again, we have factored form. To get all the information that we need the first term and the last term in the standard form. The first term will be x times x times x, which would be x to the third. And then the last term will be, this is tricky. Let me take a step back. See how this is a linear binomial, x plus 2? And this is a linear binomial, x minus 4. This x, how could we rewrite this as a linear binomial? Minus 0. Okay. So to get the last term, we would have 0 times negative 4 times 2, which is 0. So the right hand comes from the lead coefficient. It's positive, so it's up. The left hand comes from the degree. The degree is odd, so it's opposite, which would be down. The value of the y-intercept is the constant, which is 0. To get the roots, we would set each of these binomials to 0 and solve them. So the first root, or x-intercept, will be 0, and the exponent, or multiplicity, is 1. The next, x minus 4 is equal to 0, so x equals positive 4, and the multiplicity is 1. And then if x plus 2 equals 0, the root is negative 2. And the exponent is 1, so the multiplicity is 1. So with this information, we know we have a root and a y-intercept at 0. We have one at positive 4, and we have one at negative 2. We know the right hand is up. If all the multiplicities are 1, then the polynomial goes straight through all of the x-intercepts. And that is a possible sketch of the polynomial.